Hi everyone, welcome to our video on a related rate problem involving revenue. So right here I have the kind of general scenario of solving a related rates problem, and remember it's whenever you see something per time unit, like something per second or per hour or per month or whatever. And often with these business type problems we actually can skip step 1 and 2 and we jump straight to 3 and 4. All right, so use this as a reference, and also this note, when the rate is increasing, we know a unit is getting larger, the rate is positive. When a rate is decreasing, the unit's getting smaller, the rate would be negative. All right, but let's jump to one. All right, so in this scenario, we've got the monthly advertising revenue R and monthly circulation X of a magazine are related approximately by the equation R equals 8 times the square root of X squared minus 256, where R is given in thousands of dollars and X is measured in thousands of copies sold. At what rate is the advertising revenue changing if the current circulation is 20,000 copies and the circulation is decreasing at a rate of 3,000 copies per month? All right, so step 1 and step 2 in our process, we don't need a picture for this, and they already gave us the equation. So instantly we could use our revenue equation here. Revenue equation, I'm just going to write out, but I'm going to change the square root into a half power like that. All right, and then we read through it carefully and as many times as we need. Notice they say the word rate, so we know it's not a maximize problem or minimize problem. Remember, those have a different scenario. Those were in a different section. So we'll treat these ones different than those. And we also see like per month. Okay, so this also helps us figure out that we need to find this derivative with respect to time. All right, so let's find this derivative with respect to time. So we're finding derivative with respect to time, and time we usually use as t. All right, so the derivative of r would be 1, but with respect to time we're going to label it as, let's show it in blue still, so dr dt. So the derivative of r with respect to time is dr dt equals, this 8's just hanging out, 8. Now this portion actually requires the chain rule. For the chain rule, I'm going to do it in words. So the chain rule tells us to take the 1/2 and multiply the front of that x squared minus 256. And then we'd minus 1 from that power to give us negative 1/2. And then we would times everything by the derivative of this x squared minus 256. So that would be times 2x. Okay, so that is the derivative of our portion. But again, remember, so I have to make sure I do it with respect to time. Okay, so the derivative of this whole thing with respect to time, I would attach the dx dt. Okay, so we found it there, and with this scenario, well, I would want to keep simplifying. All right, so we have our derivative with respect to time. So we have dr dt equals, oops, let me see what else we have. I'm going to rearrange some things. Okay, so notice I'm going to highlight 2. So the 1/2 and the 2x, that would reduce to become just x. So I'm going to put that with the 8 in front. So I'm going to write that as 8x. And then this portion, I've got this x squared minus 256 to the negative 1/2 looks fine, and then attach the dx dt. All right, so this is what I have so far. And then now I want to think, all right, well, and we could rewrite this portion of the equation if it helps, if we want to. Let's go ahead, might as well. So dr dt equals, I'm going to write it as a fraction. So remember that negative half power would move it down to become a positive half power in the denominator. But the half power is the same as the square root, so I'm going to do that all in one big step. And again, this is optional. And then dx dt I'm still just going to leave to the side. Okay, but I have my expression, and then now my fourth step is to plug in stuff. Plug in, and let's see what we have. Okay, so I use the equation, And they told us, so let's start reading from here, where it says, where R is given in thousands of dollars and X is measured in thousands of copies sold. At what rate is the advertising revenue changing? So the rates where the so what they're asking for too, so we didn't label this yet. At what rate is the advertising revenue changing? So we're trying to find DRDT, so that's good in this scenario. If the current circulation is 20,000 copies, so this is not a rate, so they're just saying this is the number, whatever X is. Okay, so because they say the monthly circulation X, so this is our X that we would use. So let's put it right here. And it would be 20, so 20,000, because X is in thousands. So they said X is measured in thousands. So let's just keep it as 20, because it says 20,000. So let's just do 20. And the circulation is decreasing. So the circulation decreasing. So that means it's a negative rate, decreasing at a rate of 3,000 copies per month. So that's dx dt, which would equal negative 3. And again, 3,000 will do 3. Okay, so it's negative, though, because of the word decreasing. Okay, negative because decreasing. Okay, so we're going to plug those in to this equation. So we have dr dt is equal to 8 times x, which is 20, times divided by x squared, so 20 getting squared. 20 squared minus 256, all under that square root. And they said dx dt is negative 3. Okay, so let me even colorize those. So that's what we substituted into our equation. And then that makes it so we can solve for dr dt. Okay, so now let's just continue simplifying. So I have dr dt is equal to, okay, 8 times 20 is 160. Square root of 20 squared would be 400 minus 256. And then eventually we'll need to times by negative 3. Let's keep simplifying this fraction. Let me do it right here in case I start to run low. I have 160 still in the numerator. 400 minus 256 is the square root of 144. Square root of 144 is 12. Okay, so we're getting there. So we have dr dt is 160 divided by 12 times negative 3. And at this point, we could plug it all in a calculator, or I'm going to do a little simplifying. So I know, so I see it will be a negative number. So let's put the negative out front. But I know 3 and 12, I could divide each of those by 3. So let's change that to a 4, and that would be a 1. And then 160 divided by 4, I could do that. That is just going to be 40. Okay, so this all simplifies to be negative 40. Okay, so we have dr dt. Okay, so I put that in a single line. Let me put it right here. Dr dt is negative 40. Again, I'm going to cloud it, but often they want to know, hey, what does that mean in words in these application problems? Okay, so while R is the revenue, so R is the revenue, the monthly advertising revenue R, and monthly circulation of X and magazines are related approximately by this equation where R is given in thousands of dollars. Okay, so what this means, this is negative $40,000. Okay, so we've got the change in revenue. The change in revenue is, so because this is negative, we would say is decreasing at $40,000. Let's just write 40 and then put the word thousand. So there's the dollar, $40,000. So the change in revenue is decreasing at $40,000 when these are happening. So when x equals 20,000 and dx dt equals negative 3. Okay, so the rate in these subscriptions is decreasing, so that means the revenue is also decreasing. That makes sense there. Okay, so that's that. Again, with a business style problem, it's usually the equation's instantly readily available, and we could instantly start jumping into the thing. In our next videos, we'll have geometry stuff, so we'll deal with that separately, but we will start to need pictures and deal with it in a different way. All right, so thank you for watching. If you have any questions, let me know. Otherwise, I'll see you again next time.